Cool. Now recording in progress. So let's get back to the second part of this video. Okay. Formal ba na? Okay, jangan ta. So basically I want to talk about the part B. Okay. So let's see part B. Okay, answer niya. So alam niya. So which two compounds are in aqueous solution turns blue litmus paper red? Okay. Now this would actually be okay. Turn blue to red. Okay, so straight away we actually know litmus paper is actually used for acid or alkaline. Okay, so in terms of any blue to red, this is actually test for an acid. Okay, so because red is always acid, so any of the acid di atas yang kanabagi will turns them to actually the blue litmus to actually red kamo. So okay, here, okay, you'll be able to see, okay, it's either C, okay, ataupun, okay, kamu punya F, okay. So E atau C ataupun F, okay. So good, okay. Now, that would actually things yang you have to remember when it comes to actually test for an acid, okay. But again, okay, kadang-kadang ia cakap, okay, ia cakap, let's say it'd be able to react with metal, then only acid, okay? They'll be able to react with carbonate, also actually with acid, okay? That would actually be carboxylic acid, come on. So here, okay, the answer would actually be C and F, come on, because C and F actually are the acid inside them. So of course, they can actually turn the blue litmus to actually red, okay? Now, let's actually move on to the next one, okay? So any questions so far? On the first question, dahada, okay? So for that particular question, okay? So for question number 2, we actually talk about the helium, neon, argon, krypton, xenon, and radon, okay? And noble gases, a group 8, okay? Or group 0, okay? So I call noble gases. The reason kenapa actually we call it noble gases because they do not actually mix with people, okay? I mean, do not mix with others, okay? So they actually full configuration or electronic configurations, okay? So it would not actually be the same as the others because the others want to become noble, okay? For them, they can't be noble because they are born as noble. So they are unable to actually undergo any reactions, okay? So that's why actually they're in group A, okay? Now, because the valence electrons are all 8, okay, so it's fully occupied, okay. So this is one of the reasons why they're unable to actually undergo this reaction itself. Name the noble gas which actually has the greatest volume composition in air, okay. So greatest volume compositions in air, okay. So basically, in terms of that, kalau kita nilihat, okay, let's actually take a look at the punya periodic table, okay. So, okay, mana tiap periodic table macam mana kan ni? Okay. So let's move on to the last page, okay? Periodic table, okay? Yama, volume-nya, okay? Large volume, okay? So basically, what will happen? Resources load tahap pala, okay? What actually be, like, apa soalannya lagi balik tadi? Mana tiap soalannya ni? Yeah, but okay. I'm gonna drag the bar. Okay. So now, name the noble gas which has the greatest volume composition in air. Okay. So they actually have banyak dalam actually air kamu. Okay. So basically, in terms of this, and of course, okay, within the kamu punya particular all that particular noble gases. Okay. Dalam air tani paling banyak is actually argon, okay? This is actually the one that we have to actually remember. Argon is actually, although that kamu punya noble gas is actually 1%, okay? But among all, paling banyak is actually kamu punya argon kamu. Now, state one use of helium, okay? So one use of helium, and of course, okay? We use helium for kamu punya balloons, okay? Don't put di sana create Donald Duck punya voice, okay? That is actually not true. We don't actually kind of actually use it for Donald Duck punya ato, okay? But again, it is mostly actually used in balloons, okay? Then also you can actually you can actually use that helium for underwater breathing, okay, also, okay, but we still need oxygen anyway, okay. Now radon is a very unreactive, okay, so basically ia begitu unreactive, okay. Use electronic structure of radon to actually explain why, okay. So basically sebegitu kamu, okay, the noble gases is actually in group 8. Group 8, the outermost electron is actually 8, okay. So basically what happened di sana is fully occupied, so you can't add, okay, or they won't add, okay, any more electron, or they won't lose any electrons, okay. So when that actually there's no movement of electrons, then they're unable to actually undergo the reaction. So you have to remember that. So the reason kenapa, okay, most of actually the noble gases, bukan lagi most, all of noble gases are unreactive because they are fully occupied, okay. The outermost electron or outermost shell, okay, is fully occupied. So it is actually full, okay, electronic configuration. Dia cakapnya use the electronic structure. So you have to remember the first shell should actually be 2. The second onwards should actually be 8. Okay, so as long as they actually conform to that particular configuration, they are unable to actually undergo this reaction because you don't need to add, you don't need to lose. Okay, so that's the reason kenapa ia unreactive. Okay, but remember kalaunya kenapa nitrogen, okay, is actually unreactive, it is because of actually N triple bond N. It's terlampau banyak, okay, ataupun terlampau kuat. So it requires large amount of energy, okay. So this is the reason kenapa N2, okay, can only undergo reaction di 2 tempat sahaja. The first place that they can actually undergo reaction would be our upper atmosphere, okay, in the presence of lightning kamu. So the lightning would actually apa tu namanya, able to actually produce large amount of actually high voltage, super high, okay. So it actually able to break the triple bond, okay. The second place where N2 would actually be able to react would actually be in your engine, okay. The car engines or any engines sebenarnya. The reason kenapa, because of your punya engine itu is actually in a close vessels, okay, with high temperature and high pressure. So that would actually cause your punya particular activation energy would be lower. So far so good. Okay, so far so
Yes.
good. Yes, good. Okay. Okay, now let's see on the second. Okay, this is actually 2 isotopes. Apa isotopes? Okay, the answer of an isotopes. Okay, now let's actually talk about isotopes. Okay, what are isotopes? And you realize that there's a mixture of topics di sini. Okay, so be careful. Okay, so basically this is the reason kenapa it's hard to actually for examination sometimes. Okay, is because of there's a rojak dia punya particular topicnya, so it's not going to actually be the same as previously. So now for isotopes, okay, so same number of proton, but okay, different number of neutron. Okay, so okay, you will actually have the same number of proton but neutron are different. So I can say that, okay, they would actually have different nucleon number. So remember the nuclear number, okay, is your particular proton plus neutron kamu, okay? So far so good. So here you can actually see the number yang besar is what we call atomic mass or nucleon number, okay? So number yang damit di bawahan ni is what we call proton number, okay? So basically proton number is equal to electron number, okay? So on top of that would actually be the mass, okay? Relative mass, okay? AR ataupun actually kalau banyak is actually a mix. Sum of actually AR would actually equal to MR, okay, molecular mass, not Mars, okay. So molecular mass, okay. So basically in this case, you can see, okay, kalau ni actually isotopes, they're gonna actually have the bigger number would actually be different, but the smaller numbers are actually gonna be the same. But make sure, okay, it would actually be the same element, okay. So element with the same, okay, the same element with the different number of neutron but same number of proton. So the different nucleon number is what we can actually say. So now, okay, here give one similarities in the atomic structure of the two isotopes. Okay, so basically in terms of that, okay, they're gonna actually have apa similarities nya, same number of protons. So basically you're gonna actually say they have both actually have 86, okay, protons. So far so good.
Yes.
Okay, good. Now give one difference in the atomic structure of these two isotopes. So tadi sudah tahu, the different would be the number of neutrons or nucleon numbernya. So far so good. Sajuki.
Yes.
Okay, good. Okay, now let's see. Okay, move on to the next question. So we're gonna actually clear that off. Okay, since it's actually kind of like, you know, okay. Now, xenon form a compound that contains only xenon, oxygen, and fluorine. Okay, now the compound contains 21% oxygen by mass and 17% by actually fluorine by mass. So, mana xenonnya? Of course lah. Okay, kamu ada 3 sahaja elemen yang di dalam sana. So basically, you have to minus because the sum of that particular 3 tu is always equal to 100. Okay, so you have to actually deduct, okay, all that particular value to find the xenon value. Okay, then, okay, what happened is that, remember, okay, I've always mentioned this, you can actually start with step number 1, list all kamu punya particular element. So step number 1, okay, so list, okay, all element, okay, MENT. Okay, so basically list all the elements. Okay, so what are the elements? Okay, and of course here you can actually have xenon, Xe or Z. Okay, and O. Okay, and F. Okay, now, okay, so dari sini we will actually say, okay, another one, step number 2. Okay, you can actually select that. Okay, step number 2, we're gonna actually have step 2. Okay, list the percentage ataupun mass. Okay, percentage-nya, okay, in this case our mass, okay, of respective element. So here you're gonna actually have, okay, from here, xenon is actually 100, okay, minus, mana calculator? So 100 minus 22.1 minus 17.5. So xenon is 60.4, okay? So here, okay, you would actually have oxygen is 22.1, okay? Then you would actually have your fluorine would actually be 17.5, okay? Now, lapas ato, you will actually have to step number 3, okay? So step 3, I'm gonna actually put that a little bit sini, so it's gonna be kalawa, okay? So basically step number 3, okay? 3 would be, okay, mole, find mole, okay? Find mole of each. So, how to find mole? Okay, percentage over AR. Okay, so here I'm gonna actually have, okay, so it's gonna actually be, okay, 60.4 over berapa xenon? Ke Japan xenon ini berapa kan? I don't have periodic table. Okay, let me check periodic table. Alah, tertutup je lagi kat sana. Okay, sinilah. I'm gonna drag. I'm gonna drag a little bit. Xenon, mana dia? Xenon is 131. Okay. Mana dia? It's on law here. Okay, 131. 131. Okay, oxygen is berapa? Anak-anak, is 22.1 over 16. Okay, then you have another one. Betul. Fluorine. Fluorine apa anak-anak? Fluorine adalah
19.
berapa?
19.
19. Kejap. Okay, so it's 19. Okay, 17.5 divided by 19. Okay, and then drag that a little bit. Okay, now after that, once you actually find each mole of that would actually give you about sikit lagi. Sikit lagi Tanya akan betul. Okay, so redo. Oh my god. Control. Oh my god. Okay. That's actually, what's that? Okay. Redo. I can't redo that. Okay. But again, okay. You know how the would actually be, I mean, you punya answer. Have you got the answer? Oh God, I'm gonna have to actually do this again. Okay, I don't want to do that. Okay. Let's see. Okay. It's so tiring. Okay, to do this thing. Okay. So 131. Okay, 19. Okay, I'm gonna just Jua. It's there. Oh my god. Okay. Oh my god. Luckily, okay. Luckily we still actually have that. Okay, so I'm gonna actually have this. Okay, so 60.4 divided by 131. Okay, 60.4 divided by 131. So it's about 0.46. Okay, 1. Okay, then you actually have your particular oxygen 22. Okay, 22.1 divided by 16. So it's 1.381. Okay, and another one, okay, would actually be, okay, okay, 17.95, okay, divided by 19, okay. So it's 0.921, okay. So now, after that, okay, what we're gonna actually do, we're gonna actually, okay, step number 4, okay. So we're gonna actually have that, okay. So step 4, divide everything by smallest mole. Okay. Now, okay, when we actually do that, okay, we're gonna actually have, okay, okay. So the smallest actually would be 0.461. So this is going to be 1, okay. Divide, this one is 131.81, okay. 1.381 divided by 0.461. So it's about 3, okay, approximately, okay. I mean, rounded off. So 0.921 divided by 0.461, that would be 2. Okay, so after you got that, so this last step would actually be, remember, is going to be step number 5. Just rewrite, okay, with respective, okay, rewrite the number with respective actually element. Okay, so rewrite the element with respect to okay, with respective okay, number, mole, ratio, number lah, I'll just say. Okay, now here you're gonna actually have, okay, last step, okay, so it's ZO3 and F2. Okay, everyone okay with that? Siapa ni? Siapa ni? Shudna. Yes. Okay. Everyone okay. Okay. Good. Okay. Now, FIFA. Okay, FIFA.
Yes.
Good. Okay, that's good. Okay. Now, let's see. Okay. Let me actually see next questions. Okay. So the next questions that we're gonna actually look at. Okay. Mana kah dia? Okay. Di mana dia? So I need screenshot dulu kalau kamu mau. So at least that kamu actually know what to do. Okay. Now, okay. So let's see. Okay, what we're gonna actually look at the next particular question. So I'm gonna clear that off. Okay. So move on. Okay, so a sample of a neon has a volume of 21 dm cube at room temperature and pressure. Okay, now this is actually all the information you have to underline. Okay, so you can actually put it in a box anyway. Okay, so volume of 21 at room temperature and pressure. Okay, so the temperature of the sample is increased. Okay, so temperature. Okay, increase. Okay, so what happened? Kinetic. Okay, so here kinetic energy increase. Okay, so basically, okay, pressure increase. Okay, ini apa nih? Pressure remain constant sorry. Okay, so here pressure remain constant kan? Underline nih, pressure remain constant. Describe and explain using the kinetic theory what happened to the volume of the sample. Okay, so the volume. Okay, so basically the volume would actually be higher. Okay, so why it's actually higher? Okay, the reason is because the kinetic energy increases, so they're gonna actually bump to each other. Okay, so that's why the volume actually increases. So far so good. Okay.
Yes.
Okay, good. Okay. Now, okay, any question? Belum. Okay. Now let's actually remove that. Okay, that's gonna actually see. Now the pressure of the sample actually increase. So of course, this can actually be important for us. Okay. Now the temperature remain constant. Okay. So describe and explain using kinetic particle theory what happened to the volume of the sample. The volume of the sample would actually be decreasing. Okay. Because of kenapa dia cakapnya using kinetic particle theory. Okay. So apa tu? Particles and the space between the particles would actually be limited. Okay. So that's the reason kenapa ia punya particular apa tu namanya? Okay, pressure-nya okay. Ia punya particular volume-nya decreases. So far so good. Okay, that's good. Okay, now let's see the next one. Okay, here the next one. Okay, calculate. Okay, calculate the mass of neon in 121 dm cube of sample. Okay, so you check up apa nih? Okay, 21 a sample of a volume of 21 dm cube. Okay. So of a sample, give your answer in two significant figure. Okay. So 1 mole is equal to, okay, 24 dm cube. Okay. So 1 mole, okay. So basically first step, macam saya pun lupa, see, okay. Step 1, extract info. Okay. So dia cakapnya at room temperature RTP, okay, there's 21 dm cube of neon. Okay, then what else? Okay, 1 mole of gas, okay, at RTP equal to 24 dm cube of volume. Okay, so far so good. Now, okay, dari sana, okay, I can actually find, okay, step 2, okay, find, okay, mole, oh, salah, okay, find mole of neon, okay, neon, okay, neon, okay, using 1 mole is equal to 24 dm cube. Now I have x mole equal to okay, x mole equal to 21 dm cube. Okay, then I have to cross multiply. Okay, so my answer x is equal to berapa tak? 21 divided by 24. So 21 divided by 24, 0.875, 0.875 mole. Okay, so far so good. So we have 0.875 mole of kamu punya particular atau 0.8 sama lah tu. Okay, Hudna. Okay, try to use the longer version. Okay, because this is not the final answer. Okay, so now after that, okay, once I found the mole, so I'm gonna actually use step number 3. Okay, so step 3, okay, find mass, okay, of neon, okay, using formula, okay, formula, okay, mole is equal to mass over AR. So mass equal to mole times by AR. So here mass is equal to 0.875 times by AR-nya berapa nih? Neon?
20.
20. Very good. So basically mass is equal to times 20. 17.5 gram. Everyone got that? Give your answer in two significant figure. Two significant figure, 18. Sorry, okay? Lain kali, itu 18, okay? Gram, okay? So basically 2 SF. So far so good?
Yes.
Good. Now, okay, let's actually see the next particular questions. So, ani bah screenshot ta dulu. Okay, apa-apa tu semua sekali screenshot ta dulu. Okay, kalau in the screenshot, it's okay. Okay. Now, let's see. So let's clear that off. Let's move on. Now, 2 questions. Sudah tu is on now. Okay. Now 3. Petroleum, crude oil is a mixture of hydrocarbon. Okay, so basically hydrocarbon, apa maksud hydrocarbon? Ada contain C and H. Okay, so here is actually here okay, so contain CH. Okay, then a mixture. Okay, tadi you have to understand it's a mixture. Okay, so here apa mixture? Okay, not chemically bonded. Okay, so can be separated. Okay, using kamu punya particular, okay, method kamu, whatever method it is. Okay, now, okay, yeah, yeah, you can actually use fractional distillation. Okay, now why do we use fractional distillation, not actually simple distillation? Because there are more than actually two, okay, liquids or two boiling points. Okay, so when we talk about the separating method, okay, so we have to we have to ask ourselves, okay, what am I actually going to actually separate? Are we going to separate solids, okay, liquid or gases? Okay, so if I'm gonna actually be, okay, apa tu namanya, separating solid, then I have to ask further, okay, whether the solid is soluble or insoluble. Okay, now kalau actually insoluble, then I just use filtration itself. Okay, but if the solid is soluble, okay, tadi insoluble. So if the solids are soluble, then I will actually have to use crystallization ataupun evaporation method, okay? So that is actually to actually remove them up. If it's a mixture between soluble and insoluble, then you have to do dissolving first, then filter, then baru crystallize, okay? That is actually how to separate solids, okay? Now, if you actually need to separate in terms of the liquid, then you have to ask yourself three things, okay? Are we separating because of the different boiling points? Okay. Are we separating because of actually punya colored? Okay. Ataupun okay, density. So because we're just gonna actually have this three ini. So basically, kalau actually you're separating a liquid that actually have different boiling point, then you ask yourself, is it two or more? Kalau just two, then you use simple distillation. Kalau more than two, then you use fractional distillation. Okay, because fractional distillation is more effective towards actually kamu punya a different particular boiling point, a mixture of actually liquids that more than actually two boiling points. Okay, now kalau kamu actually need kalau you want to separate solutions, okay, ataupun liquid that actually have different apa itu namanya density, then you actually use separating funnel. Okay, and or if you want to actually separate your particular pigments, okay, or liquid that actually have colored, then you can actually use paper chromatography kamu. Okay, now paper chromatography can actually be used untuk separate apa tu namanya protein, okay, but protein that don't have color, so you have to spray them up, okay, by the end of that particular separation, you have to spray them with locating agent in order to show where is the positions of punya protein. So locating agent is actually a solution that actually give color, okay, and locating agent is something that actually give color to the protein positions. Okay, so they're gonna actually give specific particular it binds to specific proteins. Okay, so it will actually tell us where is the positions of that particular protein within that particular chromatography. So that's locating agent. Okay, so it's actually something that colored that actually give you this precise location where there's actually that thing arah kamu punya paper chromatography kamu. Okay, that would be after your after you finish that particular chromatography kamu. Now, if you want to separate company gases, okay, gas is actually a bit tedious because you have to actually liquefy them. Okay, then after that, after you liquefy them, then you use fractional distillation. That's the only way, because the gas you can actually just separate them with means of just simple. Okay, I'm gonna actually choose this gas and all that, because your punya molecules are actually further apart. Away from each other, so you can actually just pinpoint I'm gonna pick this, I'm gonna pick this, put it together. We can't. So what we're gonna actually do, we're gonna actually just combine these particles together just by means of liquefying them. Okay, then we will use this fractional distillation, okay, to actually distillate ataupun to actually separate them up. Okay, is there any questions? Dada?
No.
Good. Okay, now that would actually things I really want to hear. Okay, but again, okay, I also want to hear I don't understand. Okay, so the reason kenapa. Okay, not everyone perfect. Even sa punya explanation bukan kadang ada yang actually termiss ataupun over ataupun terkurang. Okay, so basically I really want you guys to, if you feel like still not confident with it, just let me know. Okay, it's okay. Okay, I'll just re-explain again. Okay, now, okay, okay, you got to go. Okay, oh, you have tuition at 7. Okay, yeah, it's okay. Okay. Okay, you can go. Okay, we almost finished anyway. Okay, it's already 4 minutes, so we're gonna actually try to finish this off a little bit. Okay, one page and then after that we end the session. We'll continue tomorrow, inshallah. So now, by Hudna. Okay, so basically petroleum crude oil separated into fractions using as liquefy petroleum gas, petrol, gasoline, and naphtha. Now the process used to separate petroleum crude oil into fractions. Okay, that would actually be fractional distillation. So because it's a mixture of more than two. Okay, so again, okay, we use fractional distillation. Come on, name other fractions separated by petroleum or crude oil. Okay, give a large scale use of this fraction. So you actually have gasoline there. Okay, what else? Okay, naphtha, you have bitumen, diesel, paraffin, okay, or paraffin and kerosene. Okay, this is used for punya aeroplane, jet fuel, whatsoever it is. Okay, bitumen is actually for your road. Okay, then after that, what else? Okay, lubricating oil. Okay, I think. Okay, that would actually have. Okay, then heating oil. Okay, motor oil, I would just say. Okay, yeah, there's a lot. Okay, you can actually use anything. Okay, just put it there. Okay, now petroleum crude oil does not contain enough of the fractions that contain smaller hydrocarbon such as petrol, of gasoline, high portions of number carbon molecule. So now apa maksudnya ni? Now petroleum contain high portions of the large hydrocarbon molecules such as naphtha. Okay, so they're actually sebenarnya apa yang dimaksudkannya di sana tu, okay, it is actually a long hydrocarbon. Okay, the chain is long. Okay, and to describe how the demand of the smaller hydrocarbon molecules is satisfied. Okay, so we all know that. Okay, to make it actually kamu punya particular long molecule of hydrocarbon ini, okay, to be more valuable, more demand. Okay, they need to actually have specific function. So you have to chop them, okay, to make it smaller. And the process is actually called cracking. Okay, so we have to crack them, pecahkan. Okay, so we have to crack them up. So basically the naphtha is actually a very long chain of hydrocarbon. So you're gonna actually have to break them into pieces, okay, into smaller molecules, I would just say, okay, so that they actually have some other functions, okay, and that would actually be demanded by actually the users, okay, or consumers. Okay, so basically in terms of this, okay, you actually have to do crack. Okay, so cracking process where actually longer chain of hydrocarbon actually cut into a mixture of alkane and alkenes. Okay, so for so good.
Yes.
Okay, good. Ifa, okay, Ifa?
Okay.
Okay, now, okay, so basically, I think, okay, because I'm gonna actually have to do this tomorrow. Okay, so I think that's it for today first. Okay, because I really want to talk about this. This is really cool. Okay, I really want to talk more about this, and I only have less than a minute. Okay, so I don't think that is gonna actually be enough for me to actually explain a little bit more about this particular questions. Okay, so I think that's it for today. I would actually see you guys inshallah by tomorrow. I will let you guys know when. Okay, and that's it for today. Okay, if you have any questions, do actually text me up. Okay, so that's it for today. Thank you very much for your time, girls. Okay, so I'll see you again tomorrow.
Thank you, sir.
Thank you. Bye. Okay.
Bye, sir.
Bye.
Bye.